Section 2.2 deals with linear equations in one variables, and we're going to start with something that should be rather familiar to you, this idea of fraction busters. So the first types of equations, actually I'm skipping quite a few of the solving equations in this video. The homework problems you should not have any trouble with. They're pretty simple and pretty basic. But I just wanted to do a quick review when you have a rational equation. So we're going to use the idea of fraction busters. So remember, we're looking for the least common denominator, which in this case is 12. So I'm going to multiply the entire equation by 12, both sides. So I'm multiplying. If you want, you can think of it as 12 over 1. So remember how we did this. 3 goes into 12 4 times, and then we have times the x, so we get 4x. 4 goes into 12 3 times the 3 is 9, so we get minus 9. And then the 12 goes into 12 once, so those cancel, and we're just left with 2x plus 3. And now it's pretty easy to solve. So I'm going to subtract 2x from both sides. And we get 2x. I'm going to go ahead and add the 9 to both sides. And we get 2x equals 12. So x is 6. Pretty easy. So remember to use fraction busters. So these are a little more complicated, these rational equations, and we did these last year as well. Still going to use fraction busters. So what you're going to pay attention to, now this one there's no sums or differences in the denominator. So I know that a 2x, I know I'm going to have an x, and then 5 times 2 is 10. So 10x is going to be what we're going to use as that common denominator. So I'm going to multiply everything by 10x. And again, if you want to put it over 1, you can. So here the x's cancel, leaves me a 10. 10 times 1 is 10. Here the 5 cancels with the 10 and leaves a 2. 2x times 1 is 2x. Here the 2 cancels with the 10 and leaves a 5, and the x's cancel and reduce to 1. So I get a 5 times 3 is 15. So I'm going to subtract 15 from both sides. We get 2x equals negative 5, so x is negative 5 halves. So you should always, anytime we're dealing with a rational equation, you always want to look back at what you were given and make sure that by substituting the value in, you don't get 0 in the denominator. So for example, if I had gotten an answer of 0, I'd have a problem because I can't have 0 in the denominator. But here we're fine with negative 5 halves, so that's our solution. So here's another one. This one's a little bit more complicated because now my denominator involves a sum or a difference. So I have to think about my common denominator. Now remember what we've done before, and actually we did rational expressions. We're going to multiply those together. So I know that my common denominator, or what I'm going to multiply by, and I'll just do just like we did before. This is like having it over 1, so you can put that there if you want. So I'm going to need an x minus 1, and I'm going to need an x plus 1. For my fraction busters. So for this first part, the x minus 1's cancel and leaves an x plus 1 times a 3x. Okay. For the next part, nothing cancels. So I just have to multiply the 2 times x minus 1, x plus 1. And here the x plus 1's cancel and leaves me the x minus 1 times a 3. So this is what I get when I'm done with fraction busters. Now I'm going to have to distribute and multiply some things out and solve this. So here I'm going to have 3x squared plus 3x when I distribute. And what I'm going to do here, now if you recognize this, this is the difference of two squares. So remember that x minus 1 times x plus 1, you can multiply it out in a box or FOIL that. But you're going to get x squared minus 1 when you do. So then when I distribute the 2, I'm going to have 2x squared minus 2. Then we have on this side 3x minus 3. So that's what I get after I've multiplied everything out. Now I'm going to combine like terms. So I have 5x squared plus 3x minus 2 equals 3x minus 3. I can subtract 3x from both sides, so notice that my x terms cancel out. I'm left with 5x squared equals, if I add 2, I get negative 1. X squared equals negative 1/5. Well, this is interesting because we've got an issue here. X squared, I can't square a number and get a negative value. So this particular answer is going to be no solution. That was a lot of work for no solution, but it happens sometimes. Going on to the next problem. Okay, so on this one, a strategy you might want to try, don't deal with this as a quadratic. Let's go ahead and factor this. So if we do, if we go ahead and factor this, you can do a diamond problem if you want. We've got a 12 and a 7, which gives me a 4 and a 3. So I'm going to factor this, and I'm going to rewrite this. I'm going to have 13 over y plus 3 minus 12 over y plus 4 equals 18 over y plus 4 times y plus 3. Now, I didn't need a box because it was just a y squared. There was no number, no coefficient other than 1 in front of that y squared value. Okay, so now we're going to go ahead with the idea of fraction busters. And notice very conveniently, I just need to use this y plus 4 times y plus 3. But it's easier to recognize when you factor at first what values you're going to use. So I recommend you always do that. Okay, so for the first one, the y plus 3's cancel, leaves me the y plus 4 times this 13 minus, and the y plus 4's cancel, leaves me the y plus 3 times this 12. And over here, the denominator is going to cancel entirely and just leave the 18. So now I'm going to distribute. I get 13y plus 52 minus 12y. Here's a common mistake people make. When you distribute this, remember it's a negative 12, so you have a minus 36 equals 18. So when we combine like terms, we're going to have y plus 16 when we take 52 minus 36 equals 18. And so y equals 2. So I'm going to do a quick check and make sure that 2 is not a problem. If I plug the 2 in here, I get a 5, I get a 6. So it's not a problem down here. So we are good. And our answer is y equals 2. So I'm going to go ahead and do chapter 2 in 2 parts. So this was kind of the rational equation part of it, and you'll need to go ahead and watch the other part as well.